So trig identities again. Okay, so trig identities, and we're doing the sum to product, and we're going to do the product to sum. And if you read on page 558, these are the formulas you're going to need. Okay, so if you haven't read, then you probably ought to read, copy these down. Let's use Zane. So, example 1. Well, what do you think? Anybody have any ideas? It'd be better if you guys come up with the ideas than me, but I can obviously give you a hint. But anybody have any idea? Where to start? Any idea?
Can you change to cosine?
Well, let's take a look at this. You're on the right track. Cosine. Which means that we got an angle, right? This is technically an angle, right? We do the inverse of something, it's technically an angle. So if I draw a triangle, that might at least give me an idea. Okay, so I'm going to draw a triangle, okay? So I'm going to draw my little triangle over to the side. Theta, right? So this is theta. So let me rewrite this whole thing as sine of 2 theta, okay? It is really an angle. Cosine inverse of x really is sine of an angle, okay? So then what do I know? Well, I know if I go to my angle, cosine inverse. Cosine's the adjacent over the hypotenuse. You okay with that? Right? Cosine inverse makes an angle, but cosine of an angle as well. Well, that's the adjacent hypotenuse, right? Now, if I want to find the opposite side, just use Pythagorean theorem. I'll slide that over, do a little Pythagorean theorem, because I really need this opposite side, because I'm going to need to do sine of this thing. So let's do that. Let's go x squared plus b squared equals 1 squared, right? I'm just going a squared plus b squared equals c squared. So I need to find this other side by Pythagorean theorem. So then I'll have b squared is equal to 1 minus x squared, right? I squared the 1 and got 1. Right, I squared the 1 and got 1, and I brought the x squared over, okay? And then I'll square root that, so then b is the square root of 1 minus x squared. Okay, so that's this side right here. The squared is the square root of 1 minus x squared. Okay, I'll slide that in there, okay? How am I doing? Okay. Okay so far? So this was an angle, right? And so instead of writing as cosine inverse of x, let's just write a cosine of 2x, okay? 2 theta. Now wait a minute, that's a formula we learned actually on Friday. That's our double angle formula. So I go look for my double angle formula, and hey, there it is, sine of 2 theta. It looks exactly like that, doesn't it? Sine 2 theta, there it is. So I'm going to write that down. Let me just write down that this is equal to 2 sine theta cosine theta. Okay, all right, so far so good. Now let's use our triangle. Let's finish it up. So my answer, this sine of 2 theta would equal, let's see, be 2, the sine of the angle. So sine, let's do sine from the angle, sine of theta, opposite over hypotenuse, right? Here's my theta, sine of that, opposite of hypotenuse. So I'm going to get a square root of a 1 minus x squared over 1. I don't really need the 1, but I'll put it in there, right? So I'm thinking opposite of hypotenuse is equal to cosine, which is the adjacent over the hypotenuse. So I'm going to do my x over 1.
You know what time is slower?
What's that?
Just a little slower.
Yeah, I don't mind going slower, okay? So all I'm doing is setting up in terms of x, because the actual question says as an algebraic expression in x only. Where I'm getting there, right? I'm getting it in terms of x, right? It says sines and thetas. So I built my triangle, and if I wanted the sine of that, that's my opposite over hypotenuse in terms of x. Good. Cosine, I get my x over 1. Good, in terms of x. And that's the answer. I'm going to tidy it up, though, because it just look a little nicer if I wrote it as a 2x times the square root of 1 minus x squared. So that is the sine of 2 cosine inverse of x, all right? When you get to calculus, you're going to have to do a lot of this, because you have to be able to take something and write it in a term that you can do something with it algebraically, okay, in terms of x. You're going to do things called derivatives and integrals in calculus, and it has to be in terms of x, okay? And that's why we do it.
Can you really quick show me what you did from there to there?
From here to here? Good, that's the easy part, okay? 2 times x, and then just attach. And then 1 times 1 times 1. I don't need the ones, right, Elijah? You ask the best questions. You do. I'm glad you asked these questions. No, it's great questions. Okay, example 2. All right, so sum of trig functions. So this looks like today's stuff, doesn't it? Doesn't this look like today's stuff? Sine, sine. Sine of something is a sum of trig functions. So, okay, let's go to what I had today. So I look for sine, sine. Looks like this one right here. You guys see it? It's this one right here. You guys agree? So in this case, before I do anything on the side, my theta is really going to be my 3x. And my phi is going to be my 5x, okay? Okay, that's my theta. And that's my phi, okay? So let me just write down the formula the way I have in my notes, and then we'll just evaluate it, okay? So it's going to equal then, according to my notes, it's going to equal 1/2 bracket cosine of theta minus phi minus a cosine of a theta plus phi, okay? This one's easy, honest. You're going to like this one. So let's just plug in 3x and 5x. So we're going to go, okay, 1/2. We're going to go cosine of 3x minus 5x. All right with that? Minus cosine of a 3x plus a 5x. Okay, how am I doing? Which will make a 1/2 times a cosine of a negative 2x minus a cosine of an 8x. How am I doing? You cannot subtract these. They're different. So technically that is the answer, and that's a great answer. I would take it. We could take it further. We could make it a 1/2 cosine of negative 2x minus a 1/2 cosine of 8x, right? We could bring the 1/2 through. You okay with that? Again, I would take this answer. I would take this answer. And there's one other answer the book likes, and the book on the side, little side note, the book taught us a long time ago that if you had cosine of a negative angle, it's equal to just the cosine of the angle. I know you probably don't remember that, but it's in your identities. It really is. In fact, I'll show you where that one is. I got them all. Right there, cosine of a negative angle is just cosine of the angle, right? So the book wants to take it one more time. They're going to change this to a 1/2 cosine of just 2x minus a 1/2 cosine of 8x. Again, I would take this answer. That answer is fine for me. I don't know what kind of crazy math teacher you might have in your next journey, but they may want you to take it that far, okay? And all I did is I changed that from a negative to a positive, okay? All right. Thumbs up, sideways, you okay? That one wasn't so bad, was it? Turn page. Okay, example 3. Sine of 7x plus sine of 3x as a product. Okay, I think this is what we did today, right? So let's see what I got in my notes. So take a look at notes. Okay, so it looks like it's sine, sine. Looks like this one, doesn't it? Looks like this one right here. And so I'm going to use this formula, but I'm going to let theta be 7x. I'm going to let phi be 3x. So on the side, I'm just going to let theta is 7x. I'm going to let phi be 3x, okay? And I'm just going to write down my formula, okay? So the formula I found in my notes for today, it's this one here, with the 2 sine of theta plus 2. So I'm going to rewrite. This is the formula I'm going to use. Write my 2 sine of theta plus phi over 2 times cosine of theta minus phi over 2. Okay, so I'm going really from a sum they're being added together. I'm going from a sum to a product where they're being multiplied, because there's a little times sign in here we never write. They are going from a plus to a times. Okay, now let's go ahead and simplify. Again, this is an easy one. You're going to like this one. So let's just plug the stuff in. I got to go 2 sine of, well, I'm going to go a 7x plus a 3x over 2 times a cosine of, let's see, a 7x minus a 3x over 2. I'll let you catch up, okay? I'll let you catch up. So I'm just plugging in 7x and 3x into there. And then, it gets pretty easy. Really, it does. It's going to be then a 2 sine of a 10x over 2, which we will make 5x. Just give me one more step. And a cosine of a 4x over 2, which I will make into a 2x. Just give me just the next step to make it, right? Okay, then let's finish it up. Let's call it a 2 sine of a 5x cosine of a 2x. And they're different angles, that's why you cannot multiply them, okay? That wasn't so bad, was it? Right? That wasn't so bad. Instead of follow the formula, okay? Alright, next example. Last one. Somehow, we have to prove this ugly mess, this ugly mess is going to equal just a tangent of x. Well, looks to me like it's two different forms of something we learned today. So it looks to me like, let's see, sine minus sine. So sine minus sine, it looks to me like I'm going to use this one on top. See the sine minus sine, I'm going to use this one on top. And then at the bottom I've got the cosine plus the cosine. So it looks like I'm going to use this one on the bottom, on the denominator, okay? So, right off the bat though, my theta is 3x, right? And my phi is x, okay? There's my theta and my phi. So let me write down the formulas, okay? So this one's sine minus sine. And sine minus sine, I'm going to write this identity. Okay, so I'm going to write on the top this big sine minus sine, right? I'm going to write 2 cosine of theta plus phi over 2 sine of theta minus phi over 2. Okay, all divided by, so I'm just using the first identity, okay? Use the first identity on top. And now I'm going to put the second identity on the bottom. The second identity is that cosine, cosine. Cosine plus cosine. I'm going to use that one right there, okay? So I'm going to write this 2 cosine of theta plus phi over 2 times the cosine of theta minus phi over 2. Okay, now, it's a mess, but if I put in my x's, things will start to simplify. You're going to be able to get things to cancel. It's going to be kind of nice. So let's put in what theta and phi happen to be. So we decided that theta would be 3x and phi would be regular x. So we're just going to plug the 3x and the x in for theta and phi, okay? So here I go. Let's see what we get. So I'm going to, well, first of all, do you mind if I cancel the 2's? You don't mind if I cancel the 2's, do you? Everybody good with cancel the 2's? Get rid of them. So I'm going to have on the top or the numerator, I'll have cosine of, you ready? 3x plus x over 2. Right? Sine of a 3x minus x over 2. All over. Am I going too fast? All over, okay? A cosine of a 3x plus x all over 2 times a cosine of a 3x minus an x all over 2. Okay, so it's a bit of a mess, but things are going to simplify pretty nicely here in a second, okay? And I might skip a little step because you guys are smart. If you're smart, you can figure it out, okay? You ready? 3x plus 1x is 4x divided by 2? 2x, right? You okay with that? I'm sure you're okay. So let's just make that 2x. So I got a cosine of 2x. Okay, 3 minus 1 is 2, right? 2 divided by 2 is 1, so then times the sine of x. Okay with that? Okay, 3x minus x is 2x. 2 divided by 2 is just 1x, or just x, okay? In the bottom, or the denominator. 3 plus 1 is 4, right? 3 plus 1 is 4, divided by 2 is 2. So I'm going to have a cosine of a 2x here. And then I'm going to have 3 minus 1 is 2. 2 minus 2 is 1, so I'm going to have a cosine of x here. Okay, now wait a minute. What do you see? What do you see that I see? Hopefully you see something. You guys see anything? Yes, cancel that with that, right? And what are we left with? Which is equal to what? Hey, what do I have to make it equal to? Shh. Tangent of x, which I did. Nice. Okay, so homework. We'll take a little break while I try and put this online for Zane. Page 561, 45, 49, 53, 55, 61, 65, 72, and 74, okay?